All right, let's do question number 1. This is the dynamics practice test. 7 questions. Let's start with number 1. 1.1 kilogram textbook is held against the wall. It's always great to draw a picture if there's no picture. There's a textbook there. There's a wall. Somebody is pushing. Wow, that is not in proportion to a gigantic textbook. But draw a free body diagram. Force of gravity going down. Out of the wall, a force of normal. Into the wall, the person is applying a force. And upwards is the force of friction. This is the one that holds the book in place. I guess all together they hold each other in place, but the one fighting against gravity, the friction force. The key equation to remember for this is force of friction equals the friction constant times force of normal. So we want to do a horizontal one. So horizontally, we have a force of normal and a force applied. What we get is force of normal equals force of applied. How do we get that? Sigma F equals ma, and acceleration is 0. It's not moving to the right or the left, no acceleration. And the sigma forces is Fn minus Fa, which gives us Fn equals Fa. And that is 45 newtons from the question. So vertically, it's very similar. What we get is the force of gravity equals the force of friction. How do we get that? Sigma F equals ma. And again, there's no movement up or down. So that's just 0. Fg minus force of friction equals 0. Fg equals force of friction equals mass times gravity, 1.1 times 9.8. 1.1 times 9.8, 10.78. To go back to our friend, force of friction equals mu Fn. Mu equals force of friction over force normal equals 10.78 over 45. What's that? 0.239, round up to 2 decimal places, 0.24. Okay, that's the first question. There's a table, and there's an 8 kilogram block and a 6 kilogram block. There's actually 2 ways to do this question, and I'll just show you the way that I do it. I do it by looking at the equation for one block and then the other block. There's another way where you can think about the total mass, but either way, you should start with a free body diagram. So we'll call this block 1. It's a fairly simple one. There's a force of tension pulling it that way, and the force of gravity going down, and a force of normal going upwards. Block 2 is even more simple. There's a force of tension going up, and a force of gravity going down. So for this block, it's like the force of tension is pulling that way. And for this block, it's like the force of gravity is winning against the force of tension. So I like to draw an equation for each block. For one, we're going to do sigma F equals ma. And that means the force of tension equals mass 1 times A. 1 is the 8 kilogram block. Now the force of tension and the acceleration are the same. So this force of tension is the same as that force of tension. Second equation, sigma F equals ma. In this case, it's Fg2 minus force of tension equals m2a. So what to do now is we plug this force of tension into that equation. m2g minus m1a equals m2a. m2g equals m1a plus m2a. We substitute, or what do we call a fraction out? A factor, there we go. So a will be m2g over m1 plus m2. M2 was my 6 kilogram block over 6 plus 8. That's 58.8.8 over 14. That's 4.2 meters per second squared. Okay, the other part is it wants us to calculate the force of tension. So we need to plug it back either into here, the acceleration, or into there. And that one looks easier. So force of tension equals m1 times a. That's 8 times 4.2. That's 33.6 newtons. And we're going to round 2 sig figs to 34 newtons. All right. Question 3. Someone pulls on a 70 kilogram block with a force of 200. So there's already a picture here, but I like to draw it for myself. I feel like I'm understanding it as I draw it. 70 kilograms, 50 kilograms, if you've got time. 200 newtons going that way. What's the acceleration? A free body diagram. It's called block 1 and block 2. Force of tension, force of gravity, force of normal. And 2. Force of tension, force of gravity, force of normal, force applied. So again, there might be 2 ways to do it. I like to do an equation on each block. Sigma F equals ma. So the whole system is accelerating in that direction. So if we're talking horizontal here, for number 1, there's only force of tension. The other forces are vertical forces. It's m1a. Okay. 2, sigma F equals ma. Fa minus Ft equals m2a. So in the second block, its force applied is winning, pushing an acceleration in that direction against the force of tension. And we substitute this in here. Oh, my green. Fa minus m1a equals m2a. Fa equals m1a plus m2 factor a, m1 plus m2, and acceleration is Fa over 1 plus 2. It's 200 over 50 plus 70. 200 divided by 120. 1.667 repeater, and we're going to round to 2. That's 1.7 meters per second squared. We also need to calculate the tension. We can plug acceleration back into there. Force of tension equals M1 is 50 times the acceleration. That's 85 newtons. Okay. Question 4. About a tiger. He's pushing a curling rock. Can I draw a tiger? And he's got a 120 Newton force. The curling rock is 22 kilograms. There's a coefficient of friction, 0.13. There's 2 questions. Firstly, what's the acceleration? And how fast will the block be after 5.2 seconds? So we draw a free body diagram of the block. Maybe there. I'll do that a little bit bigger. It's good to draw free body diagrams a little larger. So there is a tiger force, a force applied, and there's a friction force going in the other direction. There's a force of gravity and a force of normal. So we break into horizontal and then vertical. Sigma F equals ma. So in the horizontal, we've got force applied is winning against the force of friction. Force of friction minus, I should do the one that's winning first. Force applied minus force of friction equals m, that's mass of the block, a. Okay, vertical, sigma f equals ma. In the vertical direction, what's the acceleration? 0. It's not moving up or down. So Fg minus Fn equals 0. The force of normal is the same as the force of gravity. Mass of the block times g. We can calculate that. 22 times 9.8. 215.6 newtons. 216 newtons. So the last step is to remember our equation about force of friction equals mu force normal, 0.13 times 216. 28.0 newtons. And then we plug this number into here. I'm going to draw that again. That's equation 1, Fa minus. Draw this equation again. Fa minus Ff equals ma. And what are we calculating? We're looking for acceleration. So that's Fa minus force of friction divided by the mass. So it's 120 minus 28 divided by the mass. 22. 4.18, which is 4.2 meters per second squared. So that's the acceleration. There's a second question here. How fast will the block be after 5.2 seconds? So how fast is really asking about velocity final. What's the speed at the end? This is a kinematics question smuggled in. And this is going to happen to some students sometimes. There will be a kinematics question smuggled into your dynamics test. I'm sorry, teachers do that, and I want to get you ready to face what the teachers give you. So I smuggled this in too. So with a kinematics question, this is really a 1D thing. It's just accelerating in that direction. So we write down our 5 variables, and we say, what do we know? Velocity initial, we assume 0. Velocity final is what we're looking for. The time is 5.2 seconds. We don't know and don't care about the distance. And the acceleration is 4.2. I just look up, I'm actually looking up on kinematics equations, kinematics formulas, and I find the one that has no distance. Oh, that's nice. It's a very simple one. Vf equals Vi plus A times time. That's 0. So Vf equals 4.2 times 5.2. 21.84 equals 22 meters per second. The question asked for speed, so I don't need to say a direction. It's not the vector, it's the scalar. That's the answer, 22 meters per second. Okay, that was question 4. Okay, let's do question number 5. So this one involves sliding down on an angle. There's a block, it's moving that way. The block weighs 2.0 kilograms. It's on an angle of 15 degrees. Okay, these angled free body diagrams can be a little difficult, but I always helped if I draw it real big, especially the force of gravity real big. Force of gravity, and there's a force of normal. It's accelerating that way. So we need to do like a triangle here for the force of gravity because there's components. Force of gravity parallel, force of gravity perpendicular. One of the tricks of these questions is remembering, where do I put the angle? Is it here in the top or here in the bottom? And the answer is here in the top, 15 degrees. So I'm just going to go over to the side here to calculate force of gravity perpendicular and then the other one first. And I need to remember my SOHCAHTOA. So for the force of gravity perpendicular, it is adjacent to the angle, and this one is the hypotenuse. So I'm going to use cosine. Cosine 15 equals force of gravity perpendicular divided by force of gravity. Force of gravity perpendicular equals Fg times cosine 15, which is the same as mass times gravity, 2 times 9.8 times cosine 15. Put that in the calculator. Oh, sorry. 15 times cosine. It's about 0.965 times 2 times 9.8. One trick is just to leave that in the calculator and leave the cosine 15, and then you go times 2, then you go times 9.8. It's a faster way to do it. 18.9 newtons. I also need the force of gravity parallel. And I'm going to use what? This is the opposite, and I'm going to use the hypotenuse. So I use sine. Sine 15 equals force of gravity parallel over force of gravity. Force of gravity parallel equals Fg times sine 15. So that is 2 times 9.8 sine. So I do first on my calculator 15 sine. Do the hardest thing first. 15 times 15 sine equals 0.258, and then times 2, and then times 9.8. The fastest way to do it on a scientific calculator. 5.07 newtons. All right, so back over here, we have a horizontal equation and a vertical equation. So the horizontal equation is only one force, this one, Fg parallel. So I start with my sigma F equals ma. So Fg parallel equals m times a. So I can already calculate the acceleration. So acceleration, I'm on this weird thing here, equals Fg parallel over mass, which is 5.07 divided by 2.0. And that's 2.5 meters per second squared. Okay, question 6. Now, I included 2 questions that I've called extra. There are some topics that are connected to dynamics that some teachers do and some teachers don't do. So if you're doing this test and you've got no idea what these questions are about, then don't worry. You probably didn't learn them. But if you're somewhat familiar with them, then probably your teacher covered them. So you need to self-select whether these questions are for you or not. So the first one is question 6. NASA sent a rover called Curiosity to the planet Mars. The vehicle has a mass of 899 kilograms. If the acceleration due to gravity on Mars is 3.73 meters per second squared, what is the weight of the Curiosity on Mars? Most people should be able to do this one. One of the first equations we learned in this section is force of gravity equals mass times gravity. On Earth, this g is the 9.8 meters per second squared, but it's a different number on Mars. That's that 3.73 meters per second squared. So remember, mass is kilograms, but weight is actually a force, is newtons. So this is just asking to plug these 2 numbers into this equation. Fg equals 899 times 3.73. That's it. So that's 3353 newtons. We round that to 3350 newtons. A. So my pen's a bit funny. B. What is the mass of Mars? So we have this big equation, the universal gravity equation, G m little m over r squared. This is about the force of gravity between 2 masses separated by a distance r. In this case, there's a rover on the surface of Mars, so the radius of the planet is that number r. So Fg equals gmm over r squared. We're solving for the big M. Fg times r squared equals g m m. So big M equals Fg times r squared over g little m. So Fg is what we calculated in the last one, 3350. R squared is given in the equation 3,390 kilometers. Guess what? We've got to put that into meters. 3 million squared meters. Wow. Divided by big letter G. I'm just looking that off my computer. You should have your formula sheet. 6.67 times 10 to the negative 11, some crazy number, times what? The mass of our rover, 899. Okay, to do this in my scientific calculator, I will just say what I'm doing so you can know my order. This first squared. No. Okay, 1.1 times 10 to the 3. Let's go times 3350. This one. I get 3.8 times 10 to the 16. And then I divide by this one, divided by 6.67 EE negative 11. Something really big. And divided by 899. Something really big. So I get 6.42 times 10. I've got to count lots here. My calculator didn't do it for me. 3, 6, 9, 12, 15, 18, 21, 2, 3. 23 kilograms. That's B there. Okay. Let's move on to number 7. This one is to do with a spring. Some teachers talk about the spring force. We call it K. The equation is F equals KX. Kind of a simple equation. We call this K the spring constant. So this is about a spring, and there's a mass, and it's springing down. Let's draw the free body diagram. Down as a force of gravity, and upwards there's a force, spring force. And it's saying it's in equilibrium, which means that there's no acceleration. So sigma F equals ma, that's 0. So Fk equals Fg, because Fk minus Fg equals 0. It's asking us to calculate the x. So k times x, the distance, equals mg, x equals mg over k. That is 4 times 9.8 divided by the spring constant, 350. Oops, typed that wrong. 350 equals, get 0.112, round that to 0.11 meters. There you go.